The light bulb in the shed has been burning for 11 days. Not on solar, not on a generator. No extension cord running back to the house. $15 of hardware, a spool of wire, 2 ground rods, and the earth itself doing the rest. You walk out there at midnight and it's just on, the way a heartbeat is just on. No drama, no noise, steady and indifferent to whether you understand it or not. That's the part people can't sit with. The indifference. It doesn't need you to believe in it. It was running before you walked out there, and it will keep running after you go back to bed. $15, that's the whole number. Write it somewhere, you'll see it later. You've been handed a model for electricity that has exactly one answer to every question: the grid. Something needs power, you connect it to the grid. The grid goes down, you buy a generator. The generator runs out of fuel, you're in the dark, and you call someone. Every solution inside that model costs money on a schedule that someone else controls entirely. The meter spins, the bill arrives, you pay it, you don't ask why the number went up again. That is not a utility relationship. That is a subscription you never consciously agreed to, renewed automatically every 30 days for the rest of your life. The Egyptians buried copper rods in the stone foundations of certain structures along the Nile. The Romans drove iron stakes through the clay floors of their bath complexes in configurations that no plumbing diagram from that era has ever satisfactorily explained. The ancient builders at Göbekli Tepe, who were quarrying and placing 20-ton stones 10,000 years before Hammurabi wrote his first law, arranged their formations in moisture differential orientations that modern engineers keep misidentifying as agricultural drainage. Ernst Werner von Siemens demonstrated in 1866 that a conductor interacting with a differential electromagnetic field could sustain a usable current without a combustion source. That the Earth itself could function as one pole of a living circuit if you understood how to address it correctly. He published it in full. The journals received it. Then the calculus of industry changed, and that particular branch of the tree stopped being watered. After the First World War, the factory infrastructure built to synthesize nitrates for artillery shells faced an abrupt crisis of irrelevance. The war was over. The shells were not needed. The factories were enormous, expensive, and idle. The men who owned them were not idle. They found fertilizer. They found synthetic grid infrastructure. They found that selling a farmer a bag of nitrogen every planting season, or billing a household for current every month, was a revenue model with no ceiling and no end date. A farmer who understood earth-grounded differential current collection didn't need a utility hookup for his low-draw applications. He needed a rod, a wire, and an afternoon in the right soil. That was never a technology that got tested and failed. It was a revenue stream that got quietly walked away from in favor of something with a meter on it. You've seen this your whole life and just never connected the dots. A fence post driven deep into wet ground holds a static charge you can feel with the flat of your palm on a dry morning, that faint prickle that most people write off as imagination. A wire strung between 2 different metals buried in damp soil will move the needle on a multimeter without any battery attached to it. Your car antenna receives a signal that has no transmitter within 100 miles. The ionosphere is broadcasting constantly, reflecting against the Earth's surface in a loop that has never once stopped. The planet is not a passive, inert rock waiting for you to run a wire to a power station. The Earth is the other half of a circuit that has been running since before there were people smart enough to be confused by it. Here's what you need. I want to be honest with you about every single number. 2 copper-clad ground rods, 8 feet each. These run approximately $4 a piece at any electrical supply house, any farm store, any big box home center with a plumbing aisle, $8 total. 1 spool of 16-gauge insulated copper wire, 50 feet minimum, which costs about $4. 1 ceramic or ferrite inductor coil of the kind used in AM radio filter circuits. You can pull one from any dead transistor radio sitting in a junk drawer, or order one online for under $1 if you don't have a dead radio to sacrifice. 2 alligator clip leads, which you almost certainly already own. 1 rectifier bridge, 4 diodes in a single housing, available at any electronics part supplier for 60 cents, sometimes less. 1 small capacitor bank, 2 or 3 electrolytic capacitors rated at 1,000 microfarads or above, salvaged from an old microwave transformer board, which most people have sitting in a garage or barn, and which you can buy new at a surplus electronics shop for about $3 if you need to. A multimeter to measure output. If you don't own one, go get one immediately, because you need it for everything in your life, and they cost $8 at the discount tool store. For someone starting from absolute zero, the total lands at $15 and some change. That's genuinely it. Here's the one thing most people get wrong when they first build this. They drive both rods into the ground at the same depth, in the same type of soil, parallel to each other, less than 4 feet apart, and then they stand there watching a meter that reads nothing, and they conclude that the whole idea is a lie someone put on the internet to waste their afternoon. What they've actually done is build a perfectly balanced circuit with no differential at all, Two rods at the same electrochemical potential, sitting in the same mineral medium, the same distance from the water table, cancel each other with the same elegance as two speakers playing an identical tone at identical volume in perfect phase alignment. You get silence, you get zero, you feel like a fool, and you walk back inside. But the system didn't fail. The placement failed. The principle is untouched. Think of two buckets of water connected at their bases by a tube, both sitting on a level table at the same height. Nothing moves. The water has no reason to travel in either direction. Raise one bucket 8 inches, and the water rushes immediately toward the lower one. It doesn't need convincing. It doesn't need a motor. The differential does all the work. The Earth operates on exactly this logic. It has moisture gradients, mineral concentration layers, temperature bands that shift with depth and proximity to surface water. Your job is not to fight that variation or pretend it doesn't exist. Your job is to find it, measure it with your boots and your palms before you pick up a single tool, and then place your electrodes at the two ends of the most dramatic gradient you can locate on your property. Pick your site before you pick up a rod. You want a location where the soil changes character within 10 to 15 horizontal feet. Ideally a damp zone near a downspout, a mature tree's root system, a seasonal drainage low point, or the north-facing shadow side of a structure where moisture stays trapped, and a contrasting dry zone that is higher, sandier, rockier, or south-facing and sun-baked by afternoon. The electrochemical difference between those two spots is your voltage source. It is the raised bucket. Drive the first rod into the damp zone. Drive it the full 8 feet if the soil will accept it. Rent a post driver if you're working in hard clay, or soak the ground thoroughly the night before and come back in the morning when it's workable. A rod that stops at 18 inches because the soil resisted is a rod producing a fraction of what it could. Depth matters because you are trying to reach the zone of consistent moisture, not the surface layer that dries completely by mid-morning and changes conductivity with every passing cloud. When you pull your hand away from the driven rod, and the soil immediately around it is still cool to the touch, still faintly dark, you're below the variable zone and into the stable one. Drive the second rod into the dry elevated zone. Same target depth. You want the differential between the two rods in moisture content, mineral saturation, and ambient temperature to be as wide as the terrain will give you. These are not antennas reaching for a signal from above. They are electrodes sitting in two different chemical solutions. One is in a high ion mobility medium. One is in a low ion mobility medium. The current that results from that imbalance flows toward equilibrium the same way water flows downhill. Your circuit intercepts it on the way. Strip both ends of your copper wire cleanly, about 3/4 of an inch of insulation, twisted tight so no strand is loose. Connect each rod to one input terminal of your rectifier bridge. The bridge is the translator between what the Earth gives you and what your circuit can use. The Earth produces a wandering, inconsistent, low-voltage DC potential that wobbles in polarity as conditions change throughout the day. The bridge takes that and converts it into single-direction flow, regardless of which way the current decides to run at any given moment. Think of it as a one-way valve on a water pipe. The flow can come from either direction, but it always exits the same way. Clip the output terminals of the bridge to your capacitor bank, positive to positive, negative to negative. The capacitors are polarized, and they are not forgiving about this. Mark them before you work if the labeling on the housing is faint. Clip your multimeter leads across the capacitor bank output terminals. Set the meter to DC voltage, lowest range. You should see movement within 30 seconds of connection on a good site with a clear differential. What you are looking for at this stage is not a particular number. You are looking for any deflection at all, any evidence that something is happening between the two rods, that the ground is speaking into the wire. A reading of 0.3 volts is not failure. It is confirmation that the differential exists, that your connections are mechanically solid, and that the bridge is oriented correctly. If the meter reads nothing after 90 seconds of connection, reverse the 2-rod leads going into the bridge input. The Earth's local polarity at your specific site may simply be opposite to what you assumed when you clipped the wires. Now add the inductor coil in series on the input side of the circuit, between one rod connection and the bridge input terminal. This is the component that most first-time builders either skip entirely because they don't understand it, or install incorrectly because they wire it in parallel instead of in series. The coil does what a transformer does inside a wall outlet. It smooths, conditions, and shapes the incoming signal before the rectifier and capacitor bank see it, preventing the oscillating microcurrents in the Earth's differential from simply bouncing back and forth without accumulating any net charge. If you are winding your own coil on a ferrite core salvaged from a radio board, 20 tight turns is a starting point. 40 turns gives you more inductance, a slower charge rate, and a cleaner output at low differential sites. The difference in measured output voltage between a bare connection and an inductance-conditioned connection on the same site, at the same rod positions, with the same capacitor bank, can easily be 2 to 3 times the raw figure. The coil is not optional. It is the difference between a system that charges and a system that tries. Once your capacitor bank has reached a stable charge, meaning the voltage reading on your multimeter has stopped climbing and is sitting steady at its equilibrium, not rising, not falling, just holding, you are ready to put a load on it. Start with a single white LED. One LED draws roughly 20 milliamps at 2.5 to 3 volts. It is the smallest, most forgiving test load you can choose. If your site is producing adequate differential, that LED will glow. Not like a flashlight, not blazing. A soft, clean, continuous glow with no flicker, no battery, no panel, no connection to anything on this earth except the 2 rods you drove into the ground an hour ago. Set a cup of water on the soil next to the setup, rim level, not disturbing the ground around it. Walk away. Come back 20 minutes later. If the LED is still glowing with the same quiet steadiness and the surface of the water in the cup has not moved, your system is in stable equilibrium. It is running on consistent earth differential alone with no external vibration influence. That is your smart test. The cup of water, not another instrument, not a data logger. Just a cup of still water and an LED that doesn't care whether you understand what's happening. From one LED, the scale moves naturally. One LED becomes a 4 LED strip drawing 80 milliamps, lighting a workspace at bench level with no shadow. A strip becomes a small 12-volt lighting circuit with a step-up converter added between the capacitor output and the load, which adds another $3 to the build and opens the door to standard 12-volt LED fixtures. A 12-volt lighting circuit, paired with a second rod installation in a separate differential zone on the same property and a modestly larger capacitor bank built from salvaged microwave capacitors, becomes enough sustained output to run a passive motion sensor light, a low-draw weather radio, a security camera in always-on standby mode, a small cooling fan running through summer nights. This arithmetic does not require optimism. It requires terrain awareness and patience. A single well-placed 2-rod installation on clearly differentiated soil in a temperate climate, say a low wet corner and a raised dry slope within 15 feet of each other, will produce reliably between 0.5 and 1.5 volts at current levels, ranging from microamps to low milliamps depending on soil mineral content and seasonal moisture. That is enough for LED lighting and sensor circuits running continuously. A household with 3 such installations, one near the shed on the north wet side, one along the garden perimeter where drainage water sits, one at the low corner of the property where rainwater concentrates. Feeding a shared capacitor bank through a basic diode-isolated charge controller can supply all of its low-draw lighting needs and maintain its communication and monitoring devices in a permanent passive trickle charge state without purchasing a single watt of utility power for those applications, ever. Double the rod pairs, and you roughly double the harvest surface without doubling the complexity. The wiring remains the same. The charge controller handles the additional input feeds. 10 installations distributed thoughtfully across a small homestead's natural moisture gradients, following the land's own contours, placing rods where the water table geography already creates differential, not fighting the terrain, but reading it, will collectively run a refrigerator's control board in standby mode overnight. Keep perimeter lighting burning from dusk to dawn 7 nights a week without solar input. Eliminate the baseline parasitic draw that accounts for roughly 60% of a typical household's minimum metered consumption. No bills for that 60%. No infrastructure serving that 60%. No phone call to anyone asking permission to power your own property at night. No bills. No infrastructure. No asking anyone's permission. Let one thing be said plainly, without apology and without drama. Earth differential current will not run a clothes dryer. It will not run an electric range, a hot water heater, or a well pump. The current available from geologic ionic differential is low power by fundamental nature. It is drawn from the slow electrochemical movement of a planetary system, not from a combustion reaction or a turbine spinning at 3,000 RPM. Any application drawing more than approximately 50 watts of continuous load will exhaust a practical capacitor bank faster than the Earth replenishes it at the scale of a small installation. The system rewards a change in how you think about power draw, rather than rewarding an attempt to substitute Earth current for grid current wholesale. Switch your lighting entirely to LED. Replace every high-draw passive sensor with its low-draw equivalent. Run all of your monitoring, communication, and safety lighting from the Earth array. Reserve the grid or solar for the heavy appliances that genuinely need it. The Earth differential installation is not a full replacement for utility power. It is the permanent, cost-free elimination of your baseline parasitic draw. The lighting, the sensors, the overnight monitoring that runs every hour of every day even when you think the house is off. That load, separated from your bill entirely, is the number that actually changes the shape of your monthly life. There is a room under the temple complex at Karnak, where the floor is lined with hammered copper sheet and the walls are dressed limestone. The tour guides walk groups past it without stopping. Most of the published surveys file it as ceremonial or drainage-related infrastructure. The priests who used that room understood something about what moves through damp limestone toward dry stone at night, something that needed no fire, produced no smoke, and ran most steadily in the hours before dawn when the Nile's water table was at its daily high and the surface sand was at its daily cool. That differential is still there. The limestone is still there. The copper is corroded but present. The ions in the Nile silt are still drifting in the same direction they have always drifted. What you just built is the same argument they were making, with a rectifier bridge and a spool of wire from the farm supply store. I don't know what brought you here. It doesn't matter. It works either way.